Hi guys. So in this video, we'll be looking at this question under rotational motion. So the question reads, a uniform beam weighs 200 newtons and holds a 450 load or object, which is this one here. So it has a weight of 450. As shown in the diagram, find the magnitude of the forces exerted by the beam. The forces we have F1 and F2. Those are the two forces that supports this beam. So how can we find the values of these two forces? Of course, we'll be using concepts of torque in this case because we're going to consider the object rotating in a certain direction. So to start with, since these forces are all in the y-axis or in the vertical, let's start by applying Newton's, which one? Let's apply Newton's second law of motion. We know that second law of motion states that force is a product of mass and acceleration. But in this case, this object is stationary, hence there is no motion. So we can say the summation of forces in the y-axis is equals to 0. Not mass times acceleration, but 0, simply because there's no motion. This object is stationary. It's being supported by two beams. So what are the forces acting in the y-axis? So the forces which are going up, we consider them to be positives. So we have F1 positive plus F2 positive as well. Then the forces which are going in the opposite direction, we consider them negative. So we have a negative 200 and a negative 450. Like that. So at this point now, what we can do is we can simply say F1 plus F2 is equals to, so both of, sorry, this is equals to 0. So both of these two forces can go to the other side of the equation and they give us a positive 650. Okay, let's just consider this to be equation number 1. We'll come back to it. Now let's go to our diagram. Let's discuss on the aspect of torque. The idea is we have to first choose a center of rotation, and the center of rotation must be at a point where an object can rotate about, and we can choose this point here, point A. So everything can rotate about this point. So now, how many forces are acting on this object? Starting with the same one, but since the distance at this point will be 0, so this will just consider to be a 0. So the other forces acting on this, we have this force here, and this force here. Now remember, torque, we can say torque, the summation of torque on object, in this case, summation of torque must be equals to 0. Now, rotational torque, we know that clockwise torque is negative and anti-clockwise torque is positive. So at each point, at this point, at this point, at this point, at every point where we have the force acting on the beam, we shall have torque acting on it. So let's start with this point here. So at this point, since A is the point of rotation, we're going to say this object can rotate about this point like this. Now, if you look at this type of rotation at this point, this is clockwise. Clockwise torque is negative. So what is the distance from the point of rotation? The distance is L over 2. So distance L over 2 multiplied by the negative force. Simply because it's going the clockwise direction and clockwise is negative. Let's come to this point. This point, it will also rotate in this direction. Hence, it is clockwise since this is the rotation point. So since this is clockwise, what is the distance? The distance we have L over 2. L over 2, remember we need the distance from the point of rotation to the force. So we have L over 2 and L over 4. So we're adding L over 2 plus L over 4. Our LCM is 4, of course. And put it 2 there, 2 there. So we get 2L plus L, which will give us 3 over 4L, or 3L over 4. So the distance from this point to that point, we just add these two. Hence we get, remember we're summing the versus the torques. So we get 3L over 4 times the force. Now the force, which is the weight force in this case, the force is 450, but because it's in the clockwise direction, we're going to consider it negative 450. We have one more force, which is this one here. What is the distance for that force? Remember, the length of the beam is L, so that is L over 2 plus this, so the length of the beam is L. So to this point, the length is L. Add up this and this and this, we just get L. So that is L multiplied by F2. This is equal to 0. So why is this one positive? Because this one is going in the anti-clockwise direction, and in the anti-clockwise direction, torque is positive. So from this now, let's see how it simplifies. This becomes a negative 100 L, because you know that 200 over 2, we get 100. Then what we get here times 450. So here we get a negative 338 L. So if we multiply 3 over 4 times 450, you get 338 L plus L F2, everything is equal to 0. So we can get rid of L, because we haven't been given the value of L. So we can get rid of L by simply saying, let's divide everything by L. Divide, not 4, sorry, I'm pretty sorry. Divide everything by L. So if this divides by L, we just remain with negative 100. If this divides by L, we remain with 338. This we remain with plus F2. So these two negative values can cross the cosine, hence this is equal to 0. Hence F2, if these two negative values cross the cosine, we're going to get a 438 as the value of F2. So we have found the first force, which is F2, 438. How do we find the other force, F1? We go back to this equation that we had created here. So we can say F1, so we can say from here, F1 is equals to 650 minus F2. So F1 is equals to 650 minus 438. So the value of F1, let's see what we get, 650 minus 438. We get 212 newtons. So there we go. We have the two forces, F1 and F2. So understand the concept of torque. Clockwise, torque is negative, and anti-clockwise torque is positive. And you should make sure that the distance is from the point where the force is acting to the point where you have chosen as the point of rotation of that particular object. It can be a ladder. In this case, we're using a beam. So there you have it. Thank you very much. In case you have a question, please feel free to drop it in the comments. Have a good day.